In this video, I'm going to discuss the mass balance and unit operations. These are very important concepts when designing a production process. After working out the mass flow by mass balance, a factory can manage the process operation. And, in the meanwhile, the result of this can be an indication of the factory production rate and used for working out the profit. The mass balance approach can be a factory scale production process, but it can also be a kitchen scale. The same mechanism apply. Firstly, I'm going to start with mass. Mass is the amount of weight of an object. In beer processing, we sum the mass of each ingredient to determine in the total mass of the stream. And the unit of mass is generally expressed in kilograms. In the factories, the mass is often transferred as fluid. Then, instead of only mass, we use mass flows, which was shown as mass per time unit. For example, we usually use kilogram per second in calculation. When we know the density of the stream, a mass flow may be translated to a volumetric flow rate. Here, we use cubic meter per second in calculation. In beer processing, when doing the factory design, sometimes we also use kilogram per batch when considering the fermentation. When dealing with mass, the law of mass conservation is very relevant. Within a closed system, the mass can never be created or destroyed. This closed system could, for example, be the malting step, but also a combination of several steps. Each individual step in the production process is called a unit operation. As you can see from this diagram, each production line consists of several unit operations. Let's come back to the concept. A unit operation is the physical or chemical transformation carried out in a processing equipment. For example, the fermenter is a processing equipment, and the fermentation contains both physical and chemical transformation, so a fermentation is a unit operation. When we apply the law of mass conservation to a unit operation, we end up with mass balance. Basically, it means that everything that goes into a unit operation should also go out at a certain moment. Think about a vessel sending water to the lantern tank. The water flows in will eventually flow out with just the same amount. So, in mass balance, we have input equals output. But that would mean that nothing changes. Well, input refers to the sum of all input streams, and the output refers to the sum of all output streams. So, if we were to mix water and barley and we end up with wet barley, something has definitely changed. But still, input equals output is a bit oversimplified. By now, we are missing three terms: accumulation, consumption, and production. Accumulation means that a part of the mass remains in the production unit. That is what happens in the lautering step. The husk accumulate on the filter. Of course, a mechanism needs to be present that constantly removes the husk. At a certain moment, the rate of the husk entering the machine and the rate of husk being removed is equal. This point we call it the steady state. At the steady state, the accumulation equals 0. The amount of husk that remain in the machine is constant. Production and consumption are related to all sorts of reactions, such as chemical and enzymatic reaction. For example, during fermentation, sugar is converted to carbon dioxide and alcohol. The sugar is consumed by the yeast, so the mass of sugar decreases. The yeast produce alcohol and carbon dioxide, so the masses of both increases. It's that simple. Putting everything together, you end up with a very useful expression. Accumulation equals to input minus output plus production minus consumption. Now it looks a little less simple. Let's make it simpler again. As we said, during the steady state, the accumulation equals 0. So first let's assume that we are in a steady state, which is mostly the case. We end up with this. And after rewriting, input plus production equals the output plus consumption. Look at the box. The arrow on the left is the input, and the right one is the output. If there's no production or consumption, for example, during the milling of the malt, the input simplified equals to the output again. The mass of malt equals the mass of milled malt. If there's a dynamic changes in time, for example, during the fermentation, we need to take the production and consumption into account. We do this by making multiple mass balances. One for the sugar, one for the carbon dioxide, and one for the alcohol. The input of these three components together should be equal to the components together in the output. But the mass of each component changes separately during the process. When using mass balances and the mass balance equation, we can do all kinds of calculations. Most importantly, we can calculate some unknown values from known values. For example, for the mashing process, you can calculate the amount of water you need if you know the amount of malts you have and how much wort you want to achieve. You can even calculate the amount of each raw materials you need if you want to end up with a certain amount of beer. Here, we need to use multiple unit operations, which basically means that you look at the set of unit operation as if it was one operation. To conclude, the mass balance is a very useful tool for designing a production process. Its foundations are the unit operation and the law of mass conservation. For now, take a moment to allow this concept to sink in. Then we continue our journey in the next videos.